Hello, welcome to how to solve this exponential equation. 27 to the power x minus 3 to the power x is equal to 60. We can write this 27 to the power x as 3 to the power 3 whole to the power this power x minus 3 to the power x is equal to 60. Now, according to the property of exponents, a to the power m whole to the power n is equal to a to the power n whole to the power m. We can write this power x inside the brackets and this power 3 outside the brackets. 3 to the power x whole to the power this power 3 outside the brackets minus 3 to the power x is equal to 60. Now here we have 3 to the power x and here we have 3 to the power x. So we can suppose that let 3 to the power x is equal to y, and we substitute this value y in this equation, then this equation becomes y cube minus y is equal to 60. Now we move this 60 to the left side. Y cube minus y minus 60 is equal to 0. Next, this 60 is equal to 15 times 4, and square of 4 is equal to 16. So we split this negative 1y as negative 1y as negative 16y plus 15y, y cube, and we split this minus 1y as minus 16y plus 15y minus 60 is equal to 0. Now from these two terms y cube minus 16y, we can factor out y times in bracket left y square minus 16, and from these two terms plus 15y minus 60 we can factor out positive 15 plus 15 times in bracket left y minus 16 divided by 15, 4 is equal to 0. Now this 16 is equal to 4 square. So we can factorize this expression y square minus 16 according to the algebraic identity a square minus b square is equal to a plus b times a minus b. Y times this y square minus 16 is equal to y plus 4 times y minus 4 plus 15 times y minus 4 is equal to 0. Now this expression y minus 4 is a common factor, so we can factor out this expression y minus 4. Y minus 4 times in bracket left this y times y plus 4 and this plus 15, y times y plus 4 plus 15 is equal to 0. Now from here either this expression y minus 4 is equal to 0, or this expression y times y plus 4 plus 15, y times y plus 4 plus 15 is equal to 0. From here y is equal to 4, and if we solve this one, y times y square and y times plus 4 plus 4y plus this 15 is equal to 0. Now this is a quadratic equation. First we find its discriminant and see that the discriminant is less than 0 or greater than 0. In this equation, a is equal to 1, b is equal to 4 and c is equal to 15. And discriminant d is equal to b square minus 4ac. Next, the value of b is 4 square minus 4 times value of a 1 times value of c 15, and square of 4 is 16 minus 4 times 1 4 and 4 times 15 60, and 60 minus 60 is minus 44. This is the discriminant, and because the discriminant is less than 0, so no real solutions can be found from there, and we accept only this value of y 4. The value of y is equal to 4. Now recall that we have supposed that 3 to the power x is equal to y. We have supposed 3 to the power x is equal to y. In this equation we put the value of y 4 from here. 3 to the power x is equal to value of y is 4. Now to find the value of x, we take log of both sides. Log of 3 to the power x is equal to log of 4. Now according to the property of logarithms, log of a to the power n is equal to n times log a. This power x comes here, x times log of 3 is equal to log of 4, and we divide both sides by log of 3. Next, this log of 3 will be cancelled with this log of 3, and x is equal to, according to the property of logarithms, log of a over log of b is equal to log base b of a. We can write this log of 4 over log of 3 as log base 3 of 4. This is the value of x. Now to verify this value of x, we put this value in the original equation. The original equation is 27 to the power x minus 3 to the power x is equal to 60. In this equation we put the value of x log base 3 of 4. 27 to the power log base 3 of 4 minus 3 to the power log base 3 of 4 is equal to 60. Now according to the property of logarithms, a to the power log base b of c is equal to c to the power log base b of a. We can write this 27 to the power log base 3 of 4 as 4 to the power log base 3 of 27 minus this 3 to the power log base 3 of 4 is equal to 60. Now this 27 is equal to 3 to the power 3. So we replace this 27 with this 3 to the power 3. 4 to the power log base 3 of, we replace this 27 with 3 to the power 3 minus 3 to the power log base 3 of 4 is equal to 60. Next, according to the property of logarithms, log base b of b to the power a is equal to a. This power of 4 log base 3 of 3 to the power 3 is equal to 3. So here left 4 to the power 3 minus, and according to the property of logarithms, b to the power log base b of a is equal to a. This 3 to the power log base 3 of 4 is equal to 4 is equal to 60, and 4 to the power 3 is 64 minus 4 is equal to 60, and 64 minus 4, 60 is equal to 60. You can see that the left hand side is equal to the right hand side. So it is proved that the value of x log base 3 of 4 is correct.